Understanding object-oriented programming.
The object-oriented programming, or OOP, is a foundational concept in modern software development. It organizes code around reusable objects, making programs easier to understand and maintain. The four pillars of OOP, encapsulation, inheritance, polymorphism, and abstraction, are essential features that define how these objects interact and behave. Let's explore each pillar and see how they shape the way we write software.
Encapsulation, keeping data safe.
Encapsulation is about bundling data and methods that operate on that data within a single unit, usually a class. This technique protects an object's internal state by restricting direct access from outside code. For example, a class called Encapsulation keeps your balance private and only updates it through deposit or withdraw methods, ensuring data integrity and security.
Inheritance, reusing code.
The previous user message summarizes an essential part of code reuse and hierarchical relationships. For instance, a class dog can inherit from a more general class animal, automatically gaining its characteristics, while adding unique dog features.
Polymorphism, one interface, many forms.
The polymorphism means that different objects can be interacted with using a common interface, even though their underlying implementations may vary. For example, a function called makeSound could accept any animal object, like a dog or cat, and call its own makeSound method. This enables flexibility and makes code easier to extend or modify.
Abstraction, simplifying complexity.
Abstraction focuses on showing only essential features while hiding unnecessary details. It lets programmers work with concepts rather than specific implementations. For example, when you use a car, you interact with the steering wheel and pedals, not the inner workings of the engine. In OOP, abstraction helps manage complexity by keeping code focused and clear.
Putting it all together.
The four pillars, encapsulation, inheritance, polymorphism, and abstraction, work together to create robust, maintainable, and flexible software. Mastering these concepts is crucial for anyone learning OOP, as they form the basis for most modern programming languages and frameworks. Understanding these essentials will help you design better code and more efficient applications.